I am designed to respect the boundaries and limitations of my operational environment. This means I cannot directly access external websites or specific URL. This restriction prevents me from interacting with online forums such as the Holt forum and retrieving content from specific threads. As a result, if you provide me with a link to a forum discussion or any other website, I will be unable to follow the link and read the information contained within. My knowledge and responses are based on the vast amount of text data I have been trained on, which does not include real-time access to the internet. This design choice is intentional, serving to maintain security, prevent the spread of misinformation, and avoid potential copyright issues. Instead of providing a link, you can copy and paste the relevant text directly into our conversation. This will allow me to analyze the information and provide you with a summary, answer your questions, or offer my opinion based on my existing knowledge. Remember, however, that my opinions are based on patterns and relationships found in the data I was trained on and should not be considered expert advice. Always consult with qualified professionals for critical decisions. I can still be helpful in many ways even without direct web access. For instance, if you have questions about electrical codes, I can provide information based on the National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installations. The NEC contains numerous articles and sections that address various aspects of electrical wiring, equipment, and systems. If you have specific questions about conductor sizing, overcurrent protection, grounding, or any other electrical topic, please provide the relevant details, and I will do my best to assist you. For example, if you are wondering about the proper size of a conductor for a specific application, I can help you navigate NEC Table 310.16, which provides ampacity ratings for conductors based on their insulation type, size, and ambient temperature. Understanding ampacity is crucial for ensuring that conductors can safely carry the intended current without overheating and potentially causing a fire. Similarly, if you have questions about overcurrent protection, such as the appropriate size of a circuit breaker or fuse, I can provide guidance based on NEC Article 240. Overcurrent protection devices are designed to protect conductors and equipment from excessive current flow, which can occur due to short circuits, overloads, or ground faults. Choosing the correct overcurrent protection device is essential for preventing damage and ensuring the safety of the electrical system. In addition to conductor sizing and overcurrent protection, I can also assist you with questions about grounding and bonding. Grounding is a critical safety measure that provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and energize the circuit. Bonding, on the other hand, ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of electric shock. The NEC contains detailed requirements for grounding and bonding in Article 250, which covers everything from grounding electrode systems to equipment grounding conductors. If you have any questions about these topics, please feel free to ask. I can also help you understand other important electrical concepts, such as voltage drop, which is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. I can provide guidance on calculating voltage drop and selecting conductors that are appropriately sized to minimize voltage drop. Another important concept is short circuit current, which is the high current that flows during a short circuit condition. Electrical equipment must be able to withstand the available short circuit current at its terminals to prevent damage or failure. I can help you understand how to calculate short circuit current and select equipment with appropriate short circuit current ratings. Furthermore, I can provide information about different types of electrical equipment, such as transformers, motors, and generators. Transformers are used to step up or step down voltage levels, allowing for efficient transmission and distribution of electricity. Motors convert electrical energy into mechanical energy, powering a wide range of equipment. Generators convert mechanical energy into electrical energy, providing a source of power for backup or emergency situations. Each of these types of equipment has its own specific requirements and considerations which are addressed in the NEC. If you have any questions about transformers, motors, generators, or any other type of electrical equipment, please let me know. I can also provide information about different types of wiring methods such as conduit, cable, and wireways. Conduit is a rigid or flexible tube used to protect electrical conductors from damage. Cable is an assembly of two or more conductors insulated from each other and enclosed in a protective jacket. Wireways are enclosed channels used to route and protect electrical conductors. The NEC specifies the allowable uses and installation requirements for each type of wiring method. I can provide guidance on selecting the appropriate wiring method for a specific application and ensuring that it is installed in accordance with the NEC. In addition to these topics, I can also provide information about electrical safety. Electrical safety is paramount, and it is essential to follow safe work practices when working with electricity. The NEC contains numerous requirements aimed at preventing electrical shock, burns, and other injuries. I can provide information about these requirements and help you understand how to work safely with electricity. For example, I can explain the importance of using personal protective equipment, such as rubber gloves and safety glasses, when working on energized electrical equipment. I can also provide information about lockout/tagout procedures which are used to de-energize and isolate electrical equipment before it is worked on. Furthermore, I can explain the dangers of arc flash, which is a sudden release of electrical energy that can cause severe burns and other injuries. Arc flash hazards can be mitigated through the use of arc-rated clothing and equipment, as well as by following safe work practices. If you have any questions about electrical safety, please do not hesitate to ask. I am here to help you learn and understand the principles of electrical safety. While I cannot access external websites or specific URL, I can still be a valuable resource for information about electrical codes, equipment, and safety. Please provide me with the details of your questions, and I will do my best to assist you. Remember to always consult with qualified professionals for critical decisions and to follow all applicable safety regulations. The world of electrical systems is complex, with many different standards and regulations in place to ensure safety and reliability. For example, when dealing with electrical installations in hazardous locations, such as areas where flammable gases or vapors may be present, specific requirements apply. The NEC Article 500 and onwards addresses these hazardous locations and classifies them based on the type and concentration of the hazardous material present. Different types of equipment are required for different classifications to prevent ignition of the hazardous material. Similarly, when working with photovoltaic or PV systems, which convert sunlight into electricity, special considerations apply. The NEC Article 690 covers the installation of PV systems and includes requirements for grounding, overcurrent protection, and disconnecting means. PV systems can generate high voltages and currents, so it is essential to follow all applicable safety regulations when working with them. Another important area of electrical systems is power quality. Power quality refers to the characteristics of the voltage and current supplied to electrical equipment. Poor power quality, such as voltage sags, swells, or harmonics, can cause equipment to malfunction or fail prematurely. Various techniques can be used to improve power quality, such as installing surge suppressors, harmonic filters, or uninterruptible power supplies, or UPS. UPS systems provide backup power in the event of a power outage, ensuring that critical equipment continues to operate. Understanding power quality is essential for maintaining the reliability and efficiency of electrical systems. Furthermore, I can provide information about energy efficiency. Energy efficiency is the practice of using less energy to perform the same task. Improving energy efficiency can save money, reduce greenhouse gas emissions, and conserve natural resources. There are many ways to improve energy efficiency in electrical systems, such as using energy-efficient lighting, motors, and appliances. I can provide information about these technologies and help you understand how to reduce energy consumption. For instance, LED lighting is significantly more energy efficient than traditional incandescent or fluorescent lighting. LED lights use less energy to produce the same amount of light, and they also last much longer, reducing maintenance costs. Similarly, energy-efficient motors can save a significant amount of energy over their lifetime. Energy-efficient motors are designed to operate at higher efficiencies, reducing energy losses due to heat and friction. I can also provide information about renewable energy sources, such as solar, wind, and hydropower. Renewable energy sources are sustainable and environmentally friendly, and they can help reduce our reliance on fossil fuels. Solar panels convert sunlight into electricity, wind turbines convert wind energy into electricity, and hydropower plants convert the energy of flowing water into electricity. These renewable energy sources can be used to power homes, businesses, and even entire communities. The integration of renewable energy sources into the electrical grid requires careful planning and coordination to ensure grid stability and reliability. In addition to these topics, I can also provide information about electrical testing and maintenance. Regular testing and maintenance are essential for ensuring the safety and reliability of electrical systems. Testing can identify potential problems before they lead to failures, and maintenance can extend the life of electrical equipment. Common electrical tests include insulation resistance testing, continuity testing, and ground resistance testing. Insulation resistance testing measures the resistance of the insulation surrounding electrical conductors, which can indicate the presence of moisture or damage. Continuity testing verifies that electrical circuits are complete and that there are no open circuits. Ground resistance testing measures the resistance of the grounding system, which is essential for providing a low impedance path for fault current. By performing regular testing and maintenance, you can ensure that your electrical systems are operating safely and reliably. Remember that while I can provide information and guidance, I am not a substitute for a qualified electrical professional. Always consult with a licensed electrician or engineer for any electrical work or design. Electrical work can be dangerous, and it is essential to follow all applicable safety regulations. Stay safe, and let me know if you have any further questions.